Traffic engineering? What is this, a service provider course? The reality is that inside the data center, we're going to need to be able to use this traffic engineering concept to put the UCS traffic flows where we want them. One of the coolest parts about UCS is how much control we have over the networking environment. And so let's take advantage of that and let's send those traffic flows where we want them. Let's dive in. Let's start to apply these networking concepts to real-world applications. Here I've got a hypervisor drawn out with a pair of vSwitches in the virtual space. Each virtual switch has two different VNICs attached to it, and the two different VNICs are attached to two different fabrics. And so the odd-numbered VNICs on the left, those are connected up through Fabric Interconnect A, and the even-numbered VNICs are attached through Fabric Interconnect B. Now these vSwitches allow for the direct switching of traffic locally. In other words, our VMs on the left, which are attached to the vSwitch on the left, they can switch traffic directly to one another on that upstream vSwitch. And we have several different ways of taking advantage of load balancing here. First of all, we could actually configure these in a port channel. We could bundle these connections together and send them off net that way, and that way we're taking advantage of the resiliency and the load balancing of a port channel. However, whether it's virtual switching or physical switching, if we're going to configure a port channel on this side of a connection, we need to configure a port channel on the other side. And as we see here, these VNICs are going to attach up to a VETH port on the left and a VETH port on the right, and as you can imagine, we have no way of actually port channeling between those. This is why port channeling is not supported in a UCS environment that's relying on VIX. Instead, we're going to take advantage of the other methodology that virtual switches have, which is pinning. We're going to pin each individual VM to an individual upstream NIC. And so in our case, we're going to say that the VM on the left is attached to VNIC 1 and the VM on the right is pinned to VNIC 3. So we have a connection out Fabric A and we have a connection out Fabric B, by the way, for both of these vSwitches. And so one of our VMs is on Fabric A and one of our VMs is on Fabric B. And so once again, if those two VMs on the left want to switch to each other, they can switch directly on the vSwitch. But now if these VMs need to get off of the vSwitch, they're going to have to be pinned and sent upstream. Now these uplinks are interesting because we are not running spanning tree protocol on these virtual switches, and nor do we want to, by the way. We don't want all of our vSwitches to be part of our STP domain. However, we want all of these interfaces in an active state, and this is why we use pinning in order to make that happen. This should sound a little bit familiar because this is exactly what we're doing up here with the Fabric interconnects. We're running these in end host mode, and end host mode uses pinning and uses all active uplinks. Furthermore, just like we said, we can switch between the VMs on the same vSwitch, but if we want to switch between these vSwitches, we're going to have to go off the vSwitch. And so we forward our traffic out of the box up to the network in order to get switched and sent back down to the appropriate vSwitch. Well, hey, that sounds familiar as well because we talked about how if we want to stay on the fabric, in other words, we have intra-fabric communication, we can switch that locally on the Fabric interconnect. But if it's inter-fabric communication, well, we're going to have to send that off box, so to speak. We're going to have to send it up to the local area network. And then the local area network will forward it down to the appropriate Fabric interconnect. So let's apply our UCS networking to the actual virtual machine traffic we might expect in our data center. Let's start with this concept of inter-fabric communication. What if I want this virtual machine to talk to the virtual machine on the right? And in this case, let's say the VM on the right is pinned to VNIC 2, which is on Fabric A. Now we are communicating between a virtual machine on Fabric A and another virtual machine on Fabric A, but they are in two different vSwitches. So what's going to happen here? Well, let's follow the traffic path. We go up through VNIC 1. Remember, we can't switch locally on the VNIC, so we're going to get forwarded up to the Fabric interconnect, get switched between two different virtual Ethernet interfaces, forwarded back down to VNIC 2 here, and all the way down to the virtual machine. And as we see, our traffic path stays within Fabric Interconnect A's realm. We don't actually forward it up to the local area network in order to make this happen. So that's well and good. That's as good as it gets inside of a UCS environment. However, now let's take a look at a virtual machine on this vSwitch that is pinned to Fabric B through VNIC 4. And let's say we want to communicate between the same virtual machine, this one on Fabric A on a different vSwitch, and we want to connect to this VM over here that's pinned to Fabric B. Well, that traffic now is going to follow the same path to get switched up to Fabric Interconnect A. However, Fabric Interconnect A doesn't have a connection down to the virtual machine or specifically the VNIC that we're trying to communicate with. As such, we check our CAM table, there's no entry, we forward it up to the LAN. The LAN is going to forward that down to Fabric Interconnect B, and Fabric Interconnect B does see a MAC address out its virtual Ethernet interface, and so it switches it down to the virtual Ethernet interface that's mapped to VNIC 4, which then gets forwarded down to the virtual machine. And as we see here, these two VMs, which are on the same host, albeit different virtual switches, has to traverse the LAN in order to get switched. This might not be ideal in a lot of situations. For example, what if this was live migration traffic? We've talked before about this concept of VMKs. And so this might be a virtual machine, but this might have been a VMK down here. And maybe we're speaking VMK to VMK, and the VMK on the left is on fabric A, the VMK on the right is fabric B, and this was intended to be live migration traffic. Well, live migration traffic can be a very heavy bandwidth flow. And so we just sent a very heavy bandwidth flow, maybe this is a 10 gig flow that we just sent onto the local area network. Now, if the upstream switching environment can handle this, then great, but what if it can't handle it as well? Or what if it's just going to add to contention and now we're potentially dropping packets in an already busy data center network? Well, wouldn't it have been great to keep this traffic inside of a fabric interconnect? Now, just to be clear, I am aware that we would never actually do live migration within a host. In this situation, what we'd really have is a second server with a second VIC in there attached up here, and then this example would apply. As such, we want to create a goal. Our goal in the world of UCS traffic engineering is to keep major traffic flows inside of a single fabric interconnect. We don't ever want to have to hit the local area network unless we absolutely need to. Now, to be clear, we're not going to change this architectural nature of UCS. This is set in stone. Inter versus intra-fabric communication will always behave in this way. As such, if we want these major traffic flows to stay within a fabric interconnect, we're going to have to make sure those traffic flows are intra-fabric communication, with an emphasis on the intra. Let's keep these traffic flows inside the fabric interconnect, meaning that we need to bind them to the same fabric. Now, that might be easier said than done, so let's walk through different ways that we might go about accomplishing this. Now, the first way we might want to address this is on the virtual host itself. We could get onto the vSwitches and configure them for active standby communication. If they're an active standby, then all of the VMs will get pinned out the active link, which will always be pinned to a single fabric. Now, let me just clean up our drawing here so we can see what we're talking about. But what if we were to go down to these vSwitches and we were to make VNIC 1 and VNIC 2 be our active connections? Then all of the VMs in the environment and all of the VMKs would get forwarded up the active NIC. If for any reason that NIC were to go down, then, well, in that case, all of our traffic would go up to the fabric interconnect and be able to get switched locally. So this would work for us, and our redundancy, by the way, comes from the fact that we have two VNICs attaching to each vSwitch. And so if VNIC 1 were to go down, then the virtual switch itself would repin all of our VMs to VNIC 3. That's well and good, except we don't usually want to hand networking configuration off to the virtualization team, and so we'd rather have control over that ourselves, which we're fully capable of doing inside of UCS. So the second option here would be the idea of a single VNIC. If we have a single VNIC, well then, hey, problem solved, because the single VNIC will always be attached to a single fabric, so maybe fabric A in our case. At this point, we'd get rid of VNICs 3 and 4, we'd only have VNICs 1 and 2, and we'd follow the same traffic pattern as we drew out for our first option. Now, you might look at that and say, okay, Jeff, what if fabric interconnect A were to go down for any reason? Where is our redundancy? And that's a great question. Fortunately, we have an answer for that, and that is that concept of fabric failover. We remember with fabric failover that we are going to build a connection out from each VNIC out to the other fabric. As such, if fabric interconnect A were to go down for any reason, then VNIC 1 would send its traffic out to fabric interconnect B. And so we still have a fully redundant and resilient infrastructure here. However, this does cause a big problem, and that is that the hypervisor itself might start to flag errors. Hypervisors like to see resiliency, and they like to tell you when we don't have failover. And it's going to see a single vSwitch connected to a single upstream NIC, and it's going to have concerns. And so our last option, which is probably going to be our best option, is going to be to have dual VNICs, which, hey, you're saying, that's right back where we started. Other than that, we're placing them onto a single fabric. So in this case, VNIC 1 is actually going to be out fabric A, but VNIC 3 will also be out fabric A. And because they're both out fabric A, we're going to result in the same traffic flows in our environment. And because all of our VNICs are forwarded out the same fabric interconnect, well then all of our traffic will stay within that fabric interconnect. Now naturally we still need resiliency in this case, and so we're going to still rely on fabric failover for that. Both of these VNICs would fail over to fabric B if for any reason fabric A were to go down. So as we can tell, this is a big conversation, but it's one worth having. The reality is that traffic engineering will allow us to keep certain traffic flows within the world of the fabric interconnect. And that can make a big difference, especially if our upstream our upstream LAN isn't necessarily capable of handling that traffic at a given moment in time. So we have two primary options from a UCS control perspective. The first of which is to deploy simply a single VNIC per vSwitch. At that point, we'd rely on fabric failover for redundancy, but the problem with that is that the hypervisor doesn't know we have fabric failover configured, and it might think that we are not redundant. We only have a single virtual NIC. As a result, the better solution is probably to deploy two VNICs, still enabled for fabric failover. At this point, we'd direct ourselves to the same fabric. And what that's going to allow us to do is make sure that any virtual machine or any VMK that is part of that vSwitch will be accessible through the same fabric interconnect that the other vSwitches are configured for. Now, in this example, throughout this video, we took a look at a single server, but this same process applies to multiple physical servers. We might have 2 servers with 2 different VNICs, and then at that point, our live migration vSwitch, well, now, if they're both using Fabric A, for example, well, at that point, all of the live migration traffic to all of the servers in my UCS infrastructure will stay on Fabric A. And so we see that this can become very powerful, especially since the Fabric interconnects can handle that traffic at line rate. If we did want to load balance, and we'd simply place some traffic on Fabric A and some amount of those vSwitches on Fabric B. I hope this has been informative for you. I'd like to thank you for viewing.